So in this video, we're going to do our first circuit simulation of the image that was posted associated with this video. Now, I already went ahead and got the online version of this launched because I wanted to do one simulation through the online portal. The rest of the simulations and the rest of this course will be done using the computers that you would see, for instance, in the lab. Um, again, just primarily for speed. And I've already launched the program because, as is seen in the last video, I don't want to wait a lot of time for it to launch. So I'm going to go over here, and whenever we're doing an assignment or a simulation, you always want to choose the new project as opposed to the new design option. There are reasons for that. The main reason is the new project means that you're actually trying to do simulation. A new design doesn't necessarily tie into simulation, even though you might think it would. So we're going to click on New Project, and there's always several things we're going to have to fill out. We're going to have to give it a name. So let's call this Week 3 Example 1. And then you also have to select what kind of project. And for some reason, the default on the browser one is always schematic. You never want a schematic. You always want PSpice, analog, or mixed A and D. And that stands for analog digital. And then you also have to tell the location. So when you do that, we should always browse to the U drive. And then I already created a Cadence folder here. You might want to create one. You don't have to, but I definitely created a folder for it. And you see I've already even created a folder for ECE1000 and one for this example, week 3, example 1. The only reason that I have that is because, and apparently there's another folder in there, is I was trying this ahead of time, and so I had those folders already created. And so it gives me a little structure of where to store everything. And I'm going to click on the OK. And then it's going to say, do you want to create based off of an existing project? No, I want to create a blank project. And I'm going to click OK. Now what's going to happen by default here is we're going to have this blank little screen here. And before we obviously can do any simulations, what would make sense is we're going to have to build the circuit in here. And by building the circuit, we have to place components. Now there's several ways to get to the place component. If you go over here on these menu options, these buttons here, the one that looks like kind of a component with the little green plus is place part. Another way you can do it is you can just go to the place menu and part. You can also see that there is a shortcut which is P. And you'll notice there's a lot of shortcuts here. And I like using those shortcuts. And as you start using the simulator, you'll get used to them. So I'm going to hit the P button to start placing some parts or components. I say components and parts, they're interchangeable. Now, if we see right now, part list, there's nothing listed there. And that's because we don't have any libraries installed. The way this software package works is that we have to install the libraries. Now, there are already a lot of libraries that are pre-defined for us, but the reason it doesn't install them all at the beginning is that there are a lot of libraries, number one, and they can actually slow things down because basically you're generating PSpice models and loading that in for all sorts of parts that you might not want to use. And typically, in industry, you either have to use a library that's provided by the manufacturer of the chip, or some companies actually create their own PSpice models when they're actually doing design and simulation. So to add a library, we just go and hover over this Add Library little thing, and of course there's the Alt-A shortcut. I'm just going to click on that. And you want to make sure not to navigate away from here. Because you can't get back in here because it's on the C drive and you don't have access to the C drive. So let's go ahead though and see. We have a lot of different libraries here, and you can see why I might not want to add all of them in. Now there are some that we are always going to need to use for this design. For instance, we are always going to need analog. And now you can do select them one at a time. Or you can do what I'm going to do here, which is the control select. So select the other ones that you need. So analog, I'm going to scroll down to source, and I'm going to hold the control key in and select source. And you can see now there's 2 of them that it wants to be adding in. And the source library is actually for power supplies. Okay, so I'm going to open both of those, and you can see now I have some parts listed here. There is one other library that we're going to add, and that's where I move up one directory. So I'm going to just move up one level, and it is capsim. And this one is actually, I like this one because I find the capsim ground works for me really well. So I'm going to add that one as well. So I've got, and now it looks like there's no parts for capsim, but you need to add the library. Now, if I click on these different libraries, the source or the analog, you can see it, the part list changes. Now, analog is going to contain all of our basic components, resistors, capacitors, and inductors. Okay, so let's go ahead and, since we're only going to be using resistors in this course, or in this circuit, I should say, not in this course, in this circuit, I'm going to go ahead and select it, and to actually start placing it, you need to either double click on it, or you can actually, place part for enter. I just double click. And sometimes there's a delay, and you can see that there is now a resistor here. Now, you can right click and you can rotate the object. You can mirror it horizontally or vertically, but instead by left clicking on there, I actually placed one component. But instead, what I'm going to do, instead of doing that in the menu, I also am going to say that if you use the R key, you can rotate them. Now, I'm going to rotate this just so that the resistors are all in the direction that they were in the circuit diagram. Now, that's purely for my own perspective benefit. I don't have to technically do that as long as the connections are made properly. It doesn't matter if the resistors are rotated vertically, horizontally for 45 degrees, whatever. It doesn't matter. So to finish placing a component, because it looks like I'm wanting to still place resistors, you hit the escape button. Now we can see that one of my resistors is not in the correct orientation according to the circuit diagram. Even though we said it doesn't really matter, I'm going to put them all in the same orientation. So I'm going to left click on that. It's now selected, and I can still just use the same shortcut key of R to rotate it. So you can always rotate things once you've placed them. Now, the other thing I'm going to do here is I'm going to zoom in. Now, the way I zoom in, you can go to View and go to the zoom, and there's just the I and O, which works as well. But I tend to use my control key and then the mouse scroll button or scroll wheel. That zooms me in. And I'm just going to zoom in here because it's a little bit easier then for you to see and also for me to see as well. Well, the other thing I like to always place all my components first, and then I edit them and connect them up. The other component I need is a battery, 6-volt battery. So I'm going to go here and I'm going to scroll down, and there's this voltage DC. A battery is a DC voltage, and we can see, hey, look, that's that symbol we used and that I said we need to use, even though there's a slightly different version of that symbol that's in the diagram. That's my battery. Now, one thing the diagram doesn't have, which I think is, in my personal opinion, a bad diagram, is it doesn't have the most important component on there, which is ground. You cannot simulate without ground. It doesn't matter how everything's connected, you need a ground. And a way to get a ground is to go over here with this place ground. And again, I could hit the G key for a shortcut, which is what I'm going to do. I'm going to bring it up here, and I just do the default one, 0/capsim. That's the reason I added that capsim library in. So I'm just going to click on that, and then I'm just going to place it at the bottom here somewhere because, we typically think of ground being at the bottom, but the other thing you want to think of is if you have a battery that you're simulating, the ground is going to be on the other end of the battery, regardless of what else is going on in the circuitry. So I'm even going to go ahead and put it over there so that it's at the bottom end of the simulation there. Now what I'm going to go through is change all of the values. Now it says 0 volts DC. I can change this to 6, and I can type VDC if I want to, or I can just write 6. 6 VDC or 6 is going to be the same thing. I often leave the VDC out and I just say 6. So that means this is 6 volts. Now, if you were to, for instance, do something like 6M, that would be 6 millivolts. And we definitely don't want that. So we want 6 volts. Okay, now we're going to change all these capacitances and not capacitances, resistances. And now the resistances in the first example, they're kind of low. They're not necessarily a really realistic value set of resistors, but that's okay. We're just, again, using this to do our first simulation. So I'm going to change this to a 20, to a 30. And to change it, I'm just double clicking on this, 60, and then 10. All right, so I've got everything, all my components down. They're all the correct values. Now I get to just wire everything up. Now, there is over here this place wire, or again, I could go to the menu, go place wire, or I could hit the W key. And again, I like the shortcuts, so I'm going to hit the W key. Now my mouse cursor has changed. Let me show you that again. I'm going to hit the escape, saying I'm done placing wires. I go back to the pointer. But if I hit W to say I want to place wire, it goes to the crosshair. Now, I want to connect all these things, and there's these nice little square points here. So I'm just going to go inside one of these squares. You don't have to be exactly in the center of it. I'll just kind of be off the side there. And you can see it kind of puts me in the center of that square. And I can see a little wire getting built up here. Now you see if I go straight down there, it makes a connection. But like suppose I want the wire to go all the way up to here, just for no other person, because I just want to do it for visual sake, for making it easier for me to look at the diagram. Well, I can do that and then left click. And then now by left clicking, I've basically forced this wire to be, the purple wire now is forced to be that high. And I can kind of just go through, and now I can see, okay, if I want to connect it here, there's this red dot, and that's not showing an error. That's just saying if you collect here, you're going to connect the resistor and the battery up, which of course we want to connect them up. Now, the 10 ohm resistor is connected to the same wire. And now I'm going to hit the escape just for a second to show that with those 3 wires now, or those wires placed, we have this nice little pink dot. That dot means that there's a connection there. And let me show you what I mean about that. So if I were to just place another wire here, so I just placed a random wire for no purpose. I'm going to delete it here in a second. But these 2 wires are crossing. But since there's no pink dot there, there's actually no connection there. So that's like taking, 2 insulated wires, 2 wires that are wrapped in in like plastic or whatever, and just laying them on top of each other. They're not actually physically connected. They're just laying on top of each other. And so it's very important to recognize that you need to have that pink dot. And so I just selected it and hit the delete key to get rid of it. So let's go back and finish wiring everything up. So this goes down, this goes down, and then everything else is connected together at the bottom. So I'll first connect up my ground. I'll connect this. I mean, it doesn't matter the order that you connect these things. You can connect them in any order you want. Okay. Now you might say this diagram isn't exactly the same as the one I had online, because the one online had this up further. and I'm moved the wire up, and then oh wait, this bent, and oh wait, I'm supposed to move that. And you might say, well, what's going on here? The reason I'm kind of bringing this up here, and I can move things down, is all you're doing is moving wires around. But notice, like, the components themselves haven't moved, the connection points haven't changed. If I move this wire up and do something silly, there's still connections at all the correct points. So there's no need to have it where one wire is up slightly higher, like the diagram associated with this video is. The only reason to do something like that is personal preference. All right, but now we're ready to simulate. Now, simulating, the first thing you have to do is you have to create a simulation profile. Now, we are going to have to be patient here because I didn't do this ahead of time because there's no way to do that. So I need to click over here for this new simulation profile. And you can give it any name. The name is completely irrelevant, but I like to try and give the name something related to the type of simulation I'm doing. And I'm just doing a DC simulation. I'm not doing any kind of AC signal or anything else. This is just a straight DC simulation. So then I'll say DC and then create. But you could call it, you could give it the name of your pet or something. It does not matter what you call your simulation. And now we play the good old waiting game. And you can stare at my lovely face on the webcam in the bottom right as we wait for the communication with the server. And I'm actually, even though I'm on camera, I don't care. I'm going to drink some water because my throat's getting a little parched. I'd love to come up with something more entertaining to do while we wait, but yeah, I can't think of anything. Oh, if you want to see some stuff in the background there on my shelf while we're waiting. This right here, this is an old transformer. This right here is a very old method of measuring resistance. Construction hat for when we were breaking ground for our new project. Various little wooden puzzle toys. And now we're finally ready. So, okay, so let's go through this menu here before I just click OK, because there's nothing we need to change at this point in this menu. We're just doing a time domain. It says transient, general settings. That's all we're doing. Runtime is only 1,000 nanoseconds, which means we're only running the simulation for 1,000 nanoseconds. And it doesn't seem like very much, but because we're doing a DC simulation, it doesn't matter how long we run this. All right. Now, when we get into further simulations, we will see that sometimes we want to change the runtime. We're also going to change the step size, and we might even click on the skip initial transient bias point calculation. So there's lots of different settings, but right now when you're doing a DC simulation, which is what we're doing, there's nothing to do, and we click on OK. And now we're ready to run the simulation. So I'm just turning something off that was already on there. Depending on how your simulator is set up, if you have any of these V, I, or W's highlighted, it's going to, once we simulate it, it will run here and show you those. But I'm going to click on the run profile, and it created a little information there. Now we get to play the waiting game again. So let me give you a tour of some fun things on my shelf while we play the waiting game. So this little black box back here, I'll bring it out, do the whole Vanna White thing. Ooh, look. This is actually this is a multimeter. So those digital multimeters that you might see, this is an old school version of one where it measures voltage, current, and resistance. And it's got like a little analog thing. So that's pretty old. But if you think that's old, that's nothing compared to this next one that I'm going to show you. This next one here, I'll even bring it forward to the camera a little bit. This right here is an ammeter. This is only used to measure current, but you can kind of see how old it is. This one, I was trying to see if it had a date on it anywhere, because sometimes they have a date for when they were last calibrated. So that's exciting. And we're done simulating at this point. So I can come back and stop showing off things in my office. We're not quite done simulating, but now we are. Okay, but the simulation thing had come up. So we're done simulating at this point. So now we can actually go through and look at some measurements here. So I'm going to go ahead and do this V, turn on the voltage. Now there's only two or three numbers, well, three numbers of voltages. We have 6 volts, 4 volts, and 0 volts. You might say, well, wait, there's more spots I need to know the voltage of. But the reality is there isn't. Because if I think about connection points, how many connection points are there in the circuit? Well, there's this one at the top that connects R1, R2, and the battery together. There's this connection, which connects these 3 resistors together. And then there's this bottom one that connects those 3 resistors and the power supply. So there are only a total of 3 connections. Now one's easy because the bottom one, which is ground, is 0 volts. So it's going to be at 0 volts. Now the top one, which is connected to the top of the battery, well, that has to be 6 volts because that's what it is, 6 volts. And then it tells me that this is 4 volts. Now I'm going to go ahead and just add some text boxes here, not because that's something I expect you guys to do in here, but it's more to illustrate some things here. So if I wanted to say the voltage across R2, well, remember we do the higher voltage minus the smaller voltage. So that'd be 6 minus 4, which equals 2 volts. And I'll just place it right there. Voltage across R2 is 6 minus 4, which is 2 volts. And then if I, for instance, was looking at the voltage across R4, that would be 4 volts minus 0 volts, which is 4, because it's the higher voltage minus the smaller voltage. Okay, and we could do R3 and R1 similarly. Now, one thing you might want to notice here is that R1, the voltage drop across R1 is going to be 6 volts. And that's because of a particular configuration that R1 is. We said that R1 is connected in parallel to the power supply. And when we say parallel, what do we mean? Well, both the top and the bottom connection of that resistor are the top and bottom connection of your battery. In fact, if you think about how household wiring is done, even though we're talking about AC with household wiring, your power outlets are wired in parallel because every outlet has 120 volts on it. And we can see actually that R4 and R3 are also in parallel. Their tops are connected together, and so are their bottoms. Now, one thing that is also something you should look at here is notice that if I look at the voltage drop across these 2 resistors here, 4 volts across this R4, 2 volts across R2, that gets me back up to 6 volts if I add those 2 voltages together. And that has to, because if I'm going from the top, and if I go down this particular path that my mouse is highlighting, I'm going down to ground. So I have to have 6 volts drop between the top and the bottom because I go from 6 volts down to 0 volts. So it very much makes sense that I get 2 volts plus 4 volts. Now, why it's 4 volts requires more information about circuit analysis, which we're not really going to talk about in this class. Okay, now let's look at, I'll leave the voltages on here. Let's look at the current as well. Now the current, again, this is the current through the different resistors. And I want to show you that you can kind of move these labels around so that, maybe they don't cover up the actual component. And so we can move those around. And we can see, again, some things here. Okay, well, there's 500 milliamps coming up through this voltage supply. But now look, there's 500 milliamps coming up into this point right here, but then look, there's 300 going down, and then there's 200 going down here. So 200 plus 300, that's equal to 500. Well, and that should make sense too, because if 500 amps is coming up, or 500 milliamps is coming up, well, then I should have that total same amount of current going down. Now look here, we have two more though. I have 200 milliamps is coming down through R2, but then look, I have 133.3 milliamps going through this resistor and 66.67 milliamps going through this resistor. And again, that should make sense to us because I've got 200 milliamps coming in here, and then it's splitting between these two resistors. Some of it's going down here, whoops, and some of it's going down here. Now, if we think about it, it makes sense that the 30 ohm resistor has more current, because what do resistors do? They resist the flow of electricity. And so the higher the resistance, the lower the current should be, because if it's higher, it's resisting more. And if you really think about this, this really makes sense because I got 30 ohms here, 60 ohms here, so I've doubled the resistance. Well, that means this current, because it's of that doubling, this is actually twice as much as this one because, well, it's much easier for the current to go through the 30 ohm resistor. And one final thing here, I know this video is getting a little long, is we can turn on power. Now I know I mentioned it in the previous video, but I'm going to mention it one more time here. I'm just moving these around so that they're able to be seeing it here. Is that I have a negative 3 watts coming out of this battery. That means that battery is delivering 3 watts of power. As a side note, that means it's continually delivering 3 watts of power, not like at just one moment in time. That's what it is constantly delivering. It's constantly delivering 3 watts of power. And we can see that this resistor's absorbing 1.8 watts, and these other resistors are also absorbing power because we said resistors can only absorb power because they're positive. And negative means you're delivering power, you're giving power to the circuit. Now, one thing you should know, and I'm probably going to put this on your assignment question, is notice that if I add up the powers, like if I add up -3, add up all these numbers keeping sign, you should get something that makes sense. And I'm going to leave it at that, and you should be able to figure out, or if you can't figure out, maybe you can look it up, or you can even, email me a question or stop by my office if I'm in, or make an appointment with me. All right, so that's our first one. We're going to still do another simulation here for this week just to get you used to doing some of these simulations.